Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to be explaining not the wonders of the world. I guess you could call it the wonders of the internet, which is Kubernetes. Kubernetes is the ultimate solution to distributed computing. So you might have wondered, what is distributed computing exactly means? So you know websites like Google, YouTube, and all that sort of stuff, which ranks one of the highest websites in the world. Everyone pretty much visits Google. This is a big problem. If you only have one laptop, it probably wouldn't be able to handle the requests that's needed by a lot of people. So for example, there's millions of requests per second, so maybe trillions of requests per second. Of course, your potato computer won't be able to handle that. That is why Google not only has just one server, but rather they have multiple servers on different regions. So they'd have their own data center on Paris, Jakarta in Indonesia, maybe in Los Angeles, and a lot more, like 50s of them. So the requests are distributed along these servers. Rather than being directed to just one place, to this one, just your laptop, they get distributed to a lot of servers, so that they, not just one server, could they won't overload by the amount of requests. So the cool thing here is that when, for example, Los Angeles, the server got down, maybe there's some maintenance, or maybe there is a blackout or something, these requests won't get served. But they can also be rerouted to these servers, so they're still able to serve requests with the fact that Los Angeles server is down. When it's up, it could again reroute the requests to that server. So, as you might know, these servers are located in different regions. One advantage that Google has is that when there's someone somewhere in the world trying to request something from Google, when they, for example, when Google only has this Los Angeles server, it will take a long time, since light is not instant, it has time, and internet is slower than light. So you can see 200 ms is probably not suitable for most people, which is why servers are placed on different regions. So users can just fetch the nearest geographically server from their place, which would return a faster response. This is really cool. This is really cool. It's super reliable. When there's one server that's down, other servers can replace that and maybe help them, and super parallel, so that not every request are directed into one computer, but rather it's distributed into many computers at the same time, and it's all super fast. Now, you might be wondering, what is Kubernetes doing here? There's this thing that called microservices. Microservices are different, its own tiny applications that is autonomous to each other. So they connect to each other to form some kind of functionality to the user, which is different from just one big server. If we have learned about something like Laravel, it's only just one server. The thing is that Laravel can only run on one server. It cannot be distributed into multiple servers. The thing with microservices is that it's like its own tiny part of Laravel that's there's a lot of them that communicate to each other. The cool thing is that these microservices are autonomous. For example, I can have this payment microservice to be replicated. So, for example, others want to do some payment, so they could just be distributed into multiple microservices, which is pretty much the essential of a distributed computing. So, for example, when this payment goes down, other payment can take its place, so that the payment is not disrupted. The cool thing is that we can distribute these microservices into servers around the world, and we can connect them to each other as if they were just tiny applications. So the users can maybe user from here can use the server to communicate to the whole network and do a lot of things and quickly, and all of that sort of stuff that distributed computing can do. So for example, the Paris data center got down. This is a problem, but not so for long, because we can just reroute the connections from one data center to another data center. So pretty much no downtime. So for example, there's a big server that got down, the entire service, like your brick application, won't go down. This is really cool. And also, there's one thing that's really cool as well. For example, you want to add a new microservice. You, for example, needed to add a new feature or something. You don't need to kind of reboot or restart your computer. You can just plug it in and connect it to another microservice. So when you want to update your application, you won't need to kind of shut down your computer and maybe update it, which take a lot of time, maintenance, and maybe at that meanwhile, as you are maintaining your system, other users might need your application, but they couldn't. That could kind of harm your maybe your reputation or something like that. There's also this thing called autoscaling. Autoscaling, which is basically means more requests, more services, but less requests, less services. When there's more requests, there's a lot of people that's trying to connect to your server. For example, when your website gets really popular out of nowhere, for example, it got viral and people wants to visit your website, Kubernetes is adding services, more services to kind of handle that load, so you won't get overloaded. But when there's not a lot of people that's visiting your website, for example, your website got kind of there's less people trying to use it, so which means Kubernetes is going to kind of scale down and remove the unneeded services, so you won't kind of spend a lot of money, so you would kind of save your spendings. So like this, when there's little users, just Kubernetes is going to provide you with enough resources to kind of handle these users, which means you're saving some money. But when there's a lot of users, Kubernetes can scale up and make new services, a lot of services to handle that load, which means your application is not going to like be slower than before. It's going to stay the same. The user won't see anything different. Just you are going to pay more. We can do this thanks to, of course, Kubernetes. So Kubernetes works like this. We provide Kubernetes with a lot of kind of skeletons of services called images. These aren't services, these aren't running, it's like a source code. So then we give Kubernetes a control over the server, and then Kubernetes is going to be instantiating those images into containers, which is going to run on the same server. The cool thing here is that we could provide Kubernetes with a lot of servers, which means that it would instantiate the services and kind of distribute it along these three servers. And then it can also serve it to the outer world by using some technology called load balancing, which essentially is going to distribute requests. For example, users from here are going to get routed the request to here, some here, so that these servers would get an equal load and they won't get overloaded. This is pretty much how big companies like Google, like Apple, YouTube, sort of stuff work. This is really fascinating because you cannot even imagine how many requests these guys actually got, and it kind of makes sense for them to kind of build this new architecture of creating server computing. Thanks for listening. I guess that's all from me. I hope this is going to be useful for you guys, discovering new things and learning new things about server architecture like microservices. I hope this is useful to you. Thanks for listening. Assalamualaikum warahmatullahi wabarakatuh.